So in this video we will be speaking about the history of artificial intelligence, of AI. This is a video in a series of videos where I will be introducing deep learning. What it is, where it comes from, how do we use it, what does it mean? And today, in this video, we will be speaking about the origin part. But the origin part is not deep learning per se, but it's artificial intelligence. What's the difference between the two? Well, artificial intelligence is more general. We will give a definition for it in a second. But it's a whole research discipline, and deep learning is just a part of it. The newest, arguably, part of it, which has recently been having a very significant impact in our everyday lives. And because of that, well, now it's a good moment to go back and see where all of this comes from. What are the motivations that led to the development of artificial intelligence, yes, and deep learning? To do that, I will be using quite a lot of materials that I lifted from publicly accessible material on the internet and that belongs to some of these people. For example, Elaine Rich from the University of Texas, Andrei Korenkov, or Corey Wynn from the University of North Carolina. Okay, these people have not endorsed this presentation in any way. They just made their materials publicly available, and I have used some of the ideas and I have introduced some of my new ideas into them. So, into this presentation. So, basically, anything that's very well done and very well thought of probably belongs to one of these guys. And anything that's weird or any opinion that may appear belongs to me. Okay, so thanks to these people for making their knowledge easily accessible to everyone, and apologies if I say something that they don't agree with. I do not mean to say that they are endorsing this in any way, and I will try not to say things that would embarrass them too much. I might have forgotten someone who also contributed some of the slides. I have tried not to do that, but if you detect that, just let me know and I will fix it. Okay, let's begin with a brief definition of what AI, artificial intelligence, is. And there are many possible definitions, but one is the AI is the study of how to make computers do things at which at the moment people are better. As you can see, this is pretty unspecific. Another one would be the study of how to teach computers to think. Okay. Why are these definitions so unspecific? Why can't we have a very precise definition of what artificial intelligence is? Well, because it's a very broad area of knowledge and a broad scientific discipline, and we will see from the beginning that it diverges into quite a lot of things that are very different from one another. But before we do that, anytime I do a presentation on artificial intelligence, I get some sort of question about Terminator or the like, or where will this lead us, and is this dangerous, or these kind of things. And I wanted to say that from my point of view, AI doesn't have to be dangerous. AI is a technology that we are developing, and it's having some super good results, and we are using it to do many positive things, and we will comment on some of them during this presentation. But all those questions led me, of course, any technology can also be used wrong, and we should think about how to use AI in a way that benefits our society and sidesteps the potential wrong uses. But having these questions, I don't have these questions when I speak about other things. I always have them when I speak about artificial intelligence, and this leaves me wondering of why is AI scary? What is it about AI that makes us uneasy? And I'm not sure what the answer is, but I'm going to hazard a couple of guesses. What you see in the picture is a drone, a toy drone that we have at home, and that, as you can see, fits in the palm of my hand. And this very small machine can do something, fly, which humans cannot do and will never be able to do. But somehow that doesn't scare us so much. We get into elevators every day, and those can lift weights that humans cannot lift. We use our cars that run faster and farther than we ever could, and we never give it a second thought. Part of that is that we are used to those technologies, or we are getting used to them, and maybe we are not as used to AI. I think up to a certain point, humans consider thinking to be our purview, and getting some computers to do something that can be seen as thinking or is thinking adjacent make us uneasy. I wanted to start with a bit of a positive message, saying that it doesn't have to be scary, it doesn't have to be dangerous, and that there is nothing magic at all about how AI works. I hope in this set of videos to give you all a better understanding of what AI works and how all of the pieces that make artificial intelligence, and in particular deep learning networks, work fit together, and how each of them work separately. And so I hope by the end of these videos you will have a bit of a better understanding of what the whole thing is. Most people don't understand how a car engine works, but it doesn't make us afraid, because we get a general idea of how the whole thing operates, and we can live with that. So that's one of the goals that I'm pursuing with artificial intelligence. There is nothing magic about it. It's a very interesting technology. It does have some potential risk, of course, as any technology, but there is nothing magic about it. There is nothing weird about it. And there is just a limited intelligence to it, as we will be discussing. Okay, let's just get to it. The history of AI is, or I have to decide to explain it as the history of two separate things. The history of abstract thought on the one hand, and the history of machines that help us think. Machines that we design to help us think. And if we think about it in this way, we can go back quite a long time. For example, in the 5th century BC, we have the first recorded texts about Aristotelian logic, and those are sets of rules that try to describe how we think, and that went on and was refined, and there are many works, and I wanted to cite one from 1305 from Ramon Llull, famous Catalan scientist and alchemist, which devised a machine for thinking. This machine was not really built, it was more, again, a way of organizing thought, so more like a system of axioms. Machines to help us think were developed all over history, and for example, Pascal developed a machine for counting, or Leibniz did the same thing. In 1725, we have Jacquard looms, which were looms that were designed to create patterns in textile, in cloth. The noticeable, important thing for us regarding these Jacquard looms is that they were, up to a point, programmable. The operator could move levers and change the result using some machine to create some patterns in the output. That's not so different from what we do with computers. And it was not so far from what happened in 1842 when Charles Babbage and mostly Ada Lovelace, Lord Byron's daughter, by the way, and pretty clearly the first programmer ever. So yes, the first programmer ever was a female. Whenever I have some female student who is a little bit uneasy about learning to program. I let her know that not only do women belong to the field of programming, but they historically and often have actually been the leaders. So a very good example is Ada Lovelace, the first programmer ever who was able to take this calculating machine, this difference engine that Charles Babbage had designed, and create programs for it. So here we have another example of how the calculating machines and the way we think and way we compute advance together. This gets bigger and bigger, and for example, with the advances in the early 20th century, with Hilbert's program to formalize mathematics and to try to find a set of rules that explain all our mathematical language, with at the same time the problems that were already identified by Gödel, or the ways to formalize and to turn all of these ideas about what can be computed and what cannot be computed in using machines or machine-like formal constructions, like the Turing machine, which is actually an automata, a way to think about how to compute things. So while this was being developed, well, the most brilliant mathematical minds of our civilization were thinking about what could be computed, what could not be computed, how would you get a machine to compute those things if you could. That led to the development of computers that could actually do that. For example, in 1945, the ENIAC computer is one of the first computers to appear, by the way. 1945, the first computer. 1946, the first bug, which did not appear in the ENIAC but on the Mark I. And all of that development in abstract thought and in machines that help us think ended up with the emergence of the first computer programming languages. In 1956, we have the Fortran programming language, which is still used today. From there on, we get a bit more of an academic development of what artificial intelligence is. We have seen basically the development of computers and how that goes hand in hand with the development of the science of how we think about thinking, about abstract thought. That came together in a very clear and academic way in 1955 in the Dartmouth Conference, where a large group of very brilliant people, and I heartily recommend this link by, I think it's John McCarthy, about what were the ideas, the goals between this Dartmouth Conference. I always loved that the most brilliant minds thinking about this huge, lofty topic of how to get computers to think, how to teach computers to think, decided to, of course, create, get together, have some dinners, do a conference, and spend lots of time speaking about this in an academic setting. That's academia for you. But this had a very significant importance in the development of this AI discipline. And in 1954 conference in Dartmouth is where the actual artificial intelligence term was coined. And from that conference and from the early development of this AI discipline came lots of exciting opportunities and lots of up to a point promises and hype. For example, Turing said that in 1950 that in about 50 years, so by the 2000, we could have computers that spoke and processed human language like humans, and we will get to this later, and predictions were made about when computers would be able to be the world chess champion, or when they could prove new mathematical theorems they could do. According to these guys, by 1985, any work a man can do. Or in the 70s, it was said that within a generation, the problem of creating AI will substantially be solved. They said in the 70s, in 1970, that in 3 to 8 years, so before 1980, they would have a machine with the general intelligence of an average human being. There were lots and lots and lots of promises floating around, of hype about this exciting new discipline where many, many brilliant minds were working. And that led to a golden age in the 60s and 70s of the 20th century of AI. All of these very brilliant people making all these bold predictions led to lots of money being invested in this discipline. And that led to flourishing in many areas that were related to this, not directly artificial intelligence, but reasoning, robotics, computer vision, areas that use some of the ideas, that use some of the results of the computer vision discipline, flourished during the 60s and the 70s. So all of this hype was very positive, not only for the area of artificial intelligence, but for many adjacent areas. And of course, AI developed very, very fast and got some amazing results. By 63, the basics of what we know today as machine learning were set. In 64, ELISA, which was a chatbot, a program that processed natural language, was developed. In 68, a logical programming language called Prolog, or in 64, one of the first expert systems, MISIN, and we will discuss about what expert systems are. So during the 60s and 70s, there were lots and lots of development, thanks to all of that money and all of the very brilliant people working in these areas. But that did not stop there. For example, let's look at the very narrow but a very interesting example, which is the development of games. And here you have this link to this website by Andrei Kurenkov, which is amazing and which I heartily recommend. But by the 50s, Claude Shannon, the father of information theory, published a paper describing how a computer could play chess. Or other researchers were building programs to play checkers. In 1967, MacHack, a computer program, reached Class C rating in chess. So it was not only that the computers could play chess, but they were getting better at it. Even in 68, Zobrist was a Go program, Go AI, that could beat some human amateurs. We will see that Go is a very complicated game. And in 1974, Cassia became the first computer chess world champion. That means that there was a world championship between computers playing chess against each other. And that in 1974, the winner was a software called Cassia. That doesn't mean that in 1974, computers were able to beat humans at chess. They were not, as we will see in a second. But all of these advances show that all of that money was being put to good use, and not only were advances being made in general AI or in robotics or computer vision, but also in things like games where very visible and very easy to relate to results were being made. A very interesting question, which has a direct effect in our days, is: did all that hype pay up? Did AI live up to that hype? Well, the short answer is probably no, but let's have a bit of a detailed look, because that's more nuanced than just saying no. For example, this first prediction about in about 50 years, an average interrogator will not have more than 70% chance of telling whether the entity they are chatting two using a keyboard and a screen is a human or a computer, and that's something that's been known or been simplified about, been called the Turing test, which is something that Turing spoke about and thought about and has been made popular in this form. Let's suppose that you have a human who is speaking to two different entities and using a computer and typing, using the keyboard and seeing the answers on the screen, and they cannot know what they cannot see who they are speaking to. And Turing said in 1950 that by the 2000, an average interrogator would not have more than a 70% chance to do that. I wanted to very quickly show you an example here. Here we have some of the pages that I have cited. This is Cookie AI, and this is a chatbot today. And we can chat to Cookie, for example, and we can see what answers they give us. So, for example, I have just said hello. I had told it before that my name is Potato, which it didn't bother the chatbot at all. And as you can see, it's programmed to give some general answers and so on. But as soon as I get into things a little bit more nuanced, you will see that it loses interest. It gives answers that are very formulaic very quickly. So, for example, it's asking me what's new, and I'm going to go on a tangent and say the definition of new. New is something that is not old. For example, here, the answer doesn't make sense. How recently? I don't think so. Why do you ask? Let me just try to pick something in its answer and say something. I ask because I am inquisitive. And I answer. What are you curious about? So it's able to process the answers that I give it and provide some sort of conversation. But it cannot engage with me in any meaningful way. This is not any chatbot, as I will tell you in a second. Let me also show some. I am curious about, let's say, lemmings. Probably, if I was speaking to a person, they would be surprised that I mentioned lemmings here out of the blue, or they would know something about lemmings and engage with me. But this chatbot is just fixing on the word curious and saying, I think I am lost. Do you have a map? So it's giving very formulaic answers from a very small pool. My point here is that this is an example of a chatbot which today in 2023 is not able to fool mostly anyone, and not at a 70% chance. Okay, so that did not happen in 2020. Maybe it's happening now. The chatbot that I have shown you is perhaps not one of the best. It's likely that there are better chatbots today, and it's not impossible that some of them could have a 70% chance of fooling a human observer. I'm not sure. I would say no, but maybe. Okay, so the part about the Turing test did not really happen. But we do have chatbots that we use for different things, customer service and answering questions. So there has been progress made in this respect. The second big declaration was about the chess. Did a computer by 1968 beat the human world champion? Well, no, that did not happen. But did that happen? That did happen in 1997. And I think that's another interesting example of how we were seeing that games is an area where advances were made, and perhaps they were not as fast as had been promised, but they did happen. And in 1997, Deep Blue bet one of the best human players ever, Garry Kasparov, and we will see how that happened, and we will see some details about how that worked, and we will see that that was artificial intelligence, definitely, but that was not deep learning, which we are interested in. And deep learning algorithms today, 2023, can work much better than those in 1997 that could already be the best human experts. So AI has mastered the art of chess, and it didn't happen in 10 years, but it did happen. They had also this idea that computers would discover and prove an important new mathematical theorem, and there have been quite a lot of advances on something called automatic demonstration, but it's hard to say. Computers have been used many times to help prove mathematical theorems, but I would not say that they have discovered a new theorem in the way that most people would understand that. This is a bit difficult to assess. They would say that machines will be capable within 20 years, so by 1985, to do any work that a man can do. That definitely has not happened. But the list of jobs that computers can do has grown and keeps growing. I mentioned client relations a while back, and maybe in a few years we can add, for example, driving to that list. Recently, we are currently in the peak of ChatGPT panic, and people are wondering whether or not writers will be out of a job because computers will be able to do their jobs. From my point of view, probably not all writers, but maybe some writers that write things that don't need to be very creative and can just need to convey some very specific information in some ways. Yeah, probably AI can do that in 2023. Minsky said that within a generation, the problems of creating artificial intelligence would be substantially solved. And from my point of view, this hasn't happened and will not happen anytime soon. An intelligence in the way that we understand it. And artificial intelligence, even today, even with the many impressive things that deep learning can do, is not, from my point of view, anywhere close to what we would consider general intelligence. This was complemented by another sententious claim that in 3 to 8 years we will have a machine with the general intelligence of an average human being. Well, it's difficult to say who is average, but in general, no. Computers can remember much better than we do. They are not average. They are way above what we can do, and they can do some deductions if we give them a set of rules. The automatic demonstrations that I was talking about before, that can happen. There are some narrow aspects where computers have advanced and are actually better than humans, but in general, average intelligence, that's not happening. We saw the chatbot before. All of these chatbots are partially motivated by this Turing paper from 1950, thinking about how we would recognize AI. And there is a link here so that you can read for more details on how that worked. But I'm interested on how the hype resulted in a guy named Loebner establishing in 1990 a grand prize of $100,000 and a gold medal, which is always nice, for the first computer whose responses were undistinguishable from a human being. So they made this big show, this big contest out of making chatbots that could uh, answer like human beings in this setting, that they lifted from that Turing paper that they adapted to their goals, and they transformed this into this Turing test. The chatbot that I demonstrated before is just one of the winners of this Loebner Prize. The winner, I think, for the last 5 years until 2019, where I think the thing was discontinued. So sometimes this AI, this idea of creating intelligence, catches the public imagination in a way that leads to some of these, let's say, shows that are very popular, not always helpful from the research point of view, and not usually serious in any way, or in any deep way. Minsky, for example, one of the fathers of artificial intelligence, said he would give money to anyone who could do away with the whole thing because it was not helping. And Loebner, with some very good humor, said that as Minsky was offering money in something related with the contest, he was in fact a co-sponsor. So we could say that many of the things reported did not happen in the timeframes that were originally predicted. So that led to some negative reports on the different disciplines in artificial intelligence. For example, machine translation was deemed very far from happening in 1966. It has happened now, probably. Minsky highlighted some limitations of the AI models that happened at that point. There were some philosophical problems, some ethical issues, and that all led to some cutting of fundings and abandonment of some of the biggest projects related to AI, like the Japanese fifth generation project on parallel computing. Very nice example of the mindset here is the 1989 book by Roger Penrose, The Emperor's New Mind, which in my opinion is one of the books that has a better title ever, because it makes this reference to the children's tale of the Emperor's New Clothes, where a very vain emperor who wants the best clothes is duped by a smart con artist into parading himself naked by telling him that the con artist has made the emperor a dress that's so fine that only smart people can see it. And the emperor parades around naked, and everyone pretends to see the dress because they don't want to be seen as being unintelligent, until one small kid just points out the obvious, that the emperor is naked. Roger Penrose makes a very compelling case that a large part of the artificial intelligence research area was not probably grounded, did not have a strong enough basis, and that some of the promises made were actually thin, hot air, and he makes that in a very eloquent way in this book, which I recommend. It's of course not up to speed with the current technology, but it's a very, very interesting reflection on how the thing developed, and on the limitations still today, on how there are things that will never be computable by machines. So we had a very big hype out of these promising beginnings of AI, some results, and then this winter of AI, some negative reports and some cutting of investment. Is that all that happened? Is that the end of AI? Well, no. In the 80s, 90s, and 2000s, the thing kept developing. And for example, there were some advancements in autonomous driving by the Stanford card, some definitions that would be very important later, like reinforcement learning, that was used to program a computer to play backgammon in 1994. There was a computer that was able to beat the human world champion at checkers, and in 1997, as we have said before, Deep Blue could beat Anatoly Garry Kasparov at chess. All of these was compounded in the 1990s with some artificial intelligence adjacent algorithms, creating the web crawlers that are the backbone of the internet. We have seen some applications of artificial intelligence in our houses from already quite a long time. For example, in 2002, iRobot created the Roomba autonomous vacuum cleaner, or there have been since 2007 challenges for autonomous cars, which is a whole subject that has developed enormously, and we are not there yet, but we are probably not too far. Since a bit more recently, 2011, 2014, there have been some AI assistant or smartphone apps which have used AI for different tasks in our everyday life.